Hello students, hope all of you are fine and healthy. Today we are going to discuss our chapter on quadrilaterals. Now let's go on to the plane curves. So can you recall what is a plane curve? Yes, you are right. A plane curve is a figure obtained by joining points on a plane without lifting the pencil. So now let us look at these plane curves. Let us try to recall the different varieties of plane curves that we have learnt in our earlier classes. Do you remember the open curves, the closed curves and the simple curves? The first two are open curves and the other two are closed. Also, the first and the fourth are simple curves, whereas the other two are not simple. But why are they not simple? Because there is an overlap in their boundaries. Today our focus will be only on the simple closed curves. A simple closed curve made of only line segments is called a polygon. Now look at these polygons and try to count the number of sides and the vertices of each of these polygons. What do you observe? In each of these polygons, what can you say about the number of sides and the number of vertices? Yes, in a polygon, the number of vertices is always equal to the number of sides. Generally, a polygon with n sides is referred to as an n-sided polygon or an n-gon. Okay, now let's see what are the names given to these polygons with 3, 4, 5, 6, 7, 8, 9 and 10 sides. A 3-sided polygon is called a triangle. A 4-sided polygon is called a quadrilateral. A 5-sided polygon is called a pentagon. A 6-sided polygon is called a hexagon. A 7-sided polygon is called a heptagon. An 8-sided polygon is called an octagon. A 9-sided polygon is called a nonagon and a 10-sided polygon is called a decagon. A vertex is a point of intersection of two or more sides in a polygon. In any polygon having 4 or more vertices, we can join any two non-consecutive vertices using a line segment. What are non-consecutive vertices? Two vertices in a polygon which are not next to each other or which do not continuously come after one another are called non-consecutive vertices. In the quadrilateral ABCD, line segments AC and BD. In the pentagon EFGHI, line segments EG, FH, GI, HE, and in the quadrilateral JKLM, line segments JL and KM. All these line segments are joining the non-consecutive vertices of the polygons and hence they are called the diagonals. A line segment joining any two non-consecutive vertices of a polygon is called its diagonal. Now look at the polygons ABCD and JKLM. Is there a difference between the two? Please observe them carefully. Yes, you are right. In the polygon JKLM, the diagonal KM is in the exterior, whereas in the polygon ABCD, both the diagonals are in its interior. A polygon in which all its diagonals are in its interior is called a convex polygon. A polygon with at least one of its diagonals at its exterior is called a concave polygon. Look at these polygons. They are all concave polygons because at least one of its diagonals is in its exterior. Let us look at some more examples. This polygon is a convex polygon because all its diagonals lie in its interior. Now look at these polygons once again. These are examples of concave polygons because at least one of its diagonals lies in its exterior. Now look at these polygons on the screen. Both of them are four-sided polygons. So they are quadrilaterals, but there is a difference between them. Can you find it out? Yes, the second polygon has got equal sides and equal angles, but the first one does not. Hence, polygons with equal sides and equal angles are called regular polygons. Here are some more examples of regular and irregular figures. Now, let us try an activity to find the sum of the interior angles of a quadrilateral. Now, let us take this quadrilateral ABCD and try to find the sum of the interior angles of this quadrilateral ABCD. So, we already have the angles A, B, C and D marked for us. So, now we will go and find the sum of these interior angles and tell what is it equal to. So, now when we add angle A plus angle B plus angle C plus angle D, what do we get? We see that 99 plus 118 plus 76 plus 67 has become equal to 360 degrees. Now, is this going to be true for only this quadrilateral ABCD or is it true for any other given quadrilateral? So, this is what we are going to find out now. So, if I change the shape of this quadrilateral, will the sum of the interior angles remain 360 degrees or will it change? So, let us go and see now. Now, I am trying to change the shape of this quadrilateral. You can see the interior angles are definitely changing. But can you see that the sum is still remaining 360 degrees only. So, let me see how I can further change this. Now see, it has taken the shape of a rectangle where all the angles have become 90 degrees. Still you can see that the sum is 360 degrees only. Now let me see if it is the same if I bring it in the form of a square maybe. Let me see how I can change it in the form of a square. So to make it a square, I am just seeing how I can reduce this. Still it's not a square. Let me see to make it a square. Yes, now it's a square. Again you can see all the sides are equal and all the angles are 90 degrees. But still the sum of the interior angles remains 360 degrees. So we have generalized that for any given quadrilateral, the sum of the interior angles will always be equal to 360 degrees. Well, that video has shown us the angle sum property for a quadrilateral. Now, let us find a simple method to find the angle sum property of any n-sided polygon. To find the angle sum property of any n-sided polygon, we have four polygons taken here: the triangle, the quadrilateral, the pentagon and the hexagon. Now, to find the angle sum property of any n-sided polygon, we are going to use the idea of splitting the polygon into smaller triangles. So, to start with, let us try to recall the angle sum property of this triangle ABC. We know that the interior angles of a triangle sum up to 180 degrees. Now, moving on, let us take the quadrilateral. We need to divide this quadrilateral into smaller triangles with the same vertices as that of a quadrilateral. Now, how do we do this? By just drawing one of its diagonals. And how do we draw a diagonal? It is just a line segment connecting any two non-consecutive vertices. So, here I am going to join G with E. And hence I have split the quadrilateral into two smaller triangles. Now I know that there are two triangles now, that is D, G, E and E, G, F. And by my angle sum property of triangles, I know that the sum of the angles of this first triangle D, G, E will be 180 degrees, and similarly the angle sum of this triangle GFE will be equal to 180 degrees. So, in all, the total sum of the angles of this quadrilateral DEFG will be sum of the angles of the first triangle plus the sum of the angles of the second triangle. So, that will make it 180 plus 180, which will be equal to 360 degrees. Now, moving on to the pentagon, again we draw the diagonals to split it into smaller triangles. So, we will do that. We have joined two non-consecutive vertices, that is I and K, and then H and K. So, now we have split the pentagon into three triangles. So, the sum of the interior angles of this pentagon, which is H, I, J, K, L, will be equal to the sum of the angles of this first triangle, which is I, J, K, plus the sum of the angles of I, K, H, and then the sum of the angles of the third triangle H, K, L. So, it will be 180 plus 180 plus 180, which is equal to 540 degrees. Then, moving on to the hexagon, again we join the non-consecutive vertices using line segments, or in other words, we are drawing its diagonals so that we are able to split the hexagon into smaller triangles. So, we could split the hexagon into 4 triangles by drawing its diagonals. So, the angle sum of this hexagon, which is N, O, P, Q, R and M, will be equal to the sum of the angles of these 4 triangles, which will be equal to 180 plus 180 plus 180 plus 180, and hence it will be equal to 720 degrees. So, splitting a given n-sided polygon into smaller triangles and then summing up the angles of these triangles will allow me to find a general formula which will give me the angle sum property of the given n-sided polygon. So, we will further go and see how we can derive this formula. So, now we can give a general formula to find the angle sum property of any n-sided polygon as n minus 2 times 180 degrees. For a polygon with 3 sides, the angle sum will be equal to 180 degrees. And how do we get this? Here, because the polygon has got 3 sides, it will be 3 minus 2 times 180 degrees, which is 1 into 180 degrees, and hence it is 180. When the polygon has got 4 sides, the angle sum will be 360 degrees. Because it is a 4-sided polygon, it will be 4 minus 2 times 180, which is equal to 2 into 180 or 360 degrees. For a 5-sided polygon, the angle sum would be 540 degrees, because there are 5 sides, and hence 5 minus 2 times 180 degrees, which will be 3 into 180 degrees, and hence 540 degrees. For a 6-sided polygon, the angle sum would be 720 degrees, because it has got 6 sides, it will be 6 minus 2, which is 4 into 180, which comes out to be 720 degrees. So, generally, if there is a polygon with n sides, the angle sum would be given as n minus 2 times 180 degrees. Now, let us do a few problems on the angle sum properties of quadrilaterals. So, we will take up the first problem. Two angles of a quadrilateral are each of measure 75 degrees and the other two angles are equal. What is the measure of these two angles? Now, we know there are 4 angles in a quadrilateral. 2 of them are given to be 75 degrees each and the other 2 are asked. So, how do we go about doing this problem? We know we have to apply the angle sum property of quadrilaterals. That is, when you are going to add all the 4 angles, we have just now learnt that they sum up to 360 degrees. So, there are 2 angles which are not known to us. So what shall we do with them? We will assume them to be x degrees and x degrees each. So now let us see how we go about doing this problem. Let ABCD be a quadrilateral where angle A equals angle C is given as 75 degrees each, and the other two angles, which are the angle B and D, are not given to us, so we assume them to be x degrees each. Then by the angle sum property of quadrilateral, we have angle A plus angle B plus angle C plus angle D equals 360 degrees. Now substituting for the angles A, B, C and D, we get this equation as 75 plus x plus 75 plus x equals 360 degrees, or in other words we get 2x equals 360 minus 150, or x is equal to 210 divided by 2, which will be 105 degrees. So each of the other two angles are of measure 105 degrees. So we'll take up one more problem now. Both pairs of opposite angles of a quadrilateral are equal and supplementary. Find the measure of each angle. When do you say two angles become supplementary? Yes, you are correct. The two angles are said to be supplementary when they sum up to 180 degrees. So it is given the opposite angles of a quadrilateral are supplementary. That means they sum up to 180 degrees. Also, the second information given is that they are equal. Now, how do we take our assumptions here? So, we'll assume this is our quadrilateral A, B, C, D. It is given that the opposite angles are equal. So, that's why it is marked as red caps there. Angle A is equal to angle C. Also, angle B equals angle D. And the second thing is that they are supplementary. So, what do you say know about angle A and angle C now? Yes, angle A plus angle C will become equal to 180 degrees and angle B plus angle D will become 180 degrees. So, let us look at the solution now. So, it is given angle A equals angle C and angle B equals angle D. Also, angle A plus angle C is given as 180 degrees and angle B plus angle D is given as 180 degrees. So, because A and C are equal, in the first equation, I will remove the C and put the A there because they are mutually equal. So, the equation will change as angle A plus angle A becomes 180 degrees, or in other words 2 times angle A is 180 degrees and hence angle A becomes 180 by 2, which will be 90 degrees. Because we know angle A and angle C are equal, we will get angle CA and angle C as 90 degrees. Also the same way when we solve the second equation, that is you replace the angle D with B, you will get 2 times B will be equal to 180 degrees. So in the same way, angle B will come out to be 90 degrees. So if angle B is 90, your D will also become 90. And hence, we can write that all the 4 angles and A, B, C and D will become 90 degrees each. Thus, each angle is a right angle in the given quadrilateral. Now, moving on to the next problem. Find the measure of each angle of a regular octagon. So, what is an octagon? An octagon is a polygon with 8 sides. Moreover, it is given it is a regular octagon. So, what can you tell about the sides? They are going to be equal. And what can you tell about the angles? They will also be equal because it is given it is a regular octagon. Now, we have to find the measure of each of its interior angle. So, these are the angles which we have to find. We already know that they are all equal because it is said it is a regular octagon. So, how many sides does an octagon have? Yes, an octagon has got 8 sides. So, the n here will be 8. Now, we just have proved how to find the sum of the interior angles of a given n-sided polygon. We have derived the formula for this in our previous activity. We know the sum of the interior angles is equal to n minus 2 times 180 degrees. where n is the number of sides of the given polygon. Now here the polygon is an octagon, so n will be substituted with 8. So when you substitute n with 8, the equation becomes 8 minus 2 times 180 degrees, or it is 6 into 180 degrees, which will be equal to 1080 degrees. Now this is not the answer we want. This is the sum of the interior angles of this given regular octagon. How many angles do we have here? Yes, we have 8 angles and they are all equal. So when I tell they are all equal, how do I get each of these angles? Yes, the total of all these angles divided by 8 will give me the measure of each of these angles. And that's exactly what I have written here. Hence, the measure of each angle will be equal to 1080 divided by 8, which will be equal to 135 degrees.
Now try this activity on your own. Take any quadrilateral A, B, C, D. Divide it into two triangles by drawing one of its diagonals. You will get 6 angles 1, 2, 3, 4, 5 and 6. Use the angle sum property of triangles and argue how the sum of the angles A plus B plus C plus D becomes 360 degrees. So try this activity on your own.
So children, I hope you enjoyed the class today. So before we close, let us try to recall the concepts that we have learned today. We have learnt about the simple curves, the closed curves and the open curves. We also have learnt about polygons and the nomenclature of the polygons based on their sides. We could classify polygons based on their diagonals. They were called the convex polygons and the concave polygons. We also could classify the polygons based on their sides and angles. They were called the regular polygons and the irregular polygons. Later, we also verified the angle sum property of quadrilaterals and extended it to any n-sided polygon. Finally, we could also solve a few problems based on the angle sum property of the quadrilaterals. So, in the next class, I shall meet you with more varieties of quadrilaterals and their properties. Thank you.